This is Dr. Charles Parker, and you're listening to CoreBrain Journal. It's a place where I connect both fresh discoveries and interesting different perspectives from advanced mind science with the realities of real people and everyday life down on Main Street. Well, welcome aboard, folks. Those of you who are interested here at CoreBrain Journal, this is Dr. Charles Parker talking to you one more time. I'm getting kind of excited because those of you who are interested in what we talk about often here at CoreBrain Journal, really the biology of mind science and really the evolution of the complexity of things that affect mind science, we have a very, very interesting guest, Dr. James Adams from the Arizona State University. Jim, thank you so much for joining us.
Thanks. Looking forward to it.
So Dr. Adams is an expert on autism and the multiplicity of effects that can turn and improve autism spectrum around. And as you know, we've had a number of people commenting on the varieties of biomedical issues. Let me read a little bit of his bio, and then we'll get started in a conversation that I know you folks are going to enjoy. So Dr. James B. Adams is a President's Professor at Arizona State University, where he directs the Autism Asperger's Research Program, though he originally taught chemical and materials engineering there a long time ago. Dr. Adams also holds a post at Southwest College of Naturopathic Medicine and teaches there. In addition, he is also the president of the Autism Society of Greater Phoenix, the co-chair of the Autism Research Institute's Scientific Advisory Committee, and has received the Autism Service Award from the Greater Phoenix chapter of the Autism Society of America. So what we're going to be talking about, folks, is a lot of different things, not the least of which is going to be how high-fiber diet can significantly turn around the whole gut microbiome situation and actually encourage brain healing. So, Jim, let's tell us a little bit. You're very deep. You have excellent credentials. I mean, you have been around the autism community for a long period of time. Tell us how you got that start. What got you walking down that path?
Well, it's very simple. My daughter was born 26 years ago, and she had major developmental delays. And at age 2, we were very concerned. At age 2.5, she was given a diagnosis of autism and intellectual disability. And the physicians at the time said, we don't know how to treat it. Go see the Autism Society and support group. And that was about the level.
That was it.
What to do. And so we began looking at behavioral interventions. And back then, the ABA therapy was very concerning to people. There were stories of abuse and using negative reinforcement. And so we just began focusing on searching for treatments for my daughter. So after a number of years, I became very frustrated, and I began shifting much of my professional research to looking at the causes of autism, how to treat it, and now how to prevent it. And we made a lot of progress in all of those areas.
See, that word prevention is really very interesting. And I think that's where a lot of individuals are going. If you really understand the biology, there are certain specific things that a person can do to actually intervene. So then you became interested. What was your first place that you cracked open the door when you said, hey, this is something, I want to chase this thing down because this is of interest? It's a long time ago, so you may not remember it, but it might be interesting to hear about.
Yeah, well, we certainly tried a great variety of different treatments with my daughter, but my wife had been to an autism conference put on by the Autism Research Institute, the oldest autism foundation in the world, a very forward-thinking integrative medicine group. And she was very intrigued by the talks there by Bernie Rimland and others on vitamins. I said, gee, vitamins, how could those possibly be important? We've known about vitamins for close to 100 years. Is it possible that nutritional deficiencies exist? As I began reading about it, it was amazing. The research on it seemed very powerful. And yes, vitamin and mineral deficiencies are quite common in the U.S. And so I said, okay, let's design what would be the optimal vitamin mineral supplement. We designed one. and then found one that was almost exactly a match to what we designed. So we used that for our first study, small, randomized, double-blind, placebo-controlled study. We found good benefits in improving sleep and improving GI issues. And so we just went on from there to do more and more studies.
That sounds interesting. So give us a quick thumbnail of what was that particular product. What did you find there that you thought that was so interesting?
Well, we went on to do several further studies of vitamins and minerals. So we did one study in which we measured the level of every vitamin, every mineral in children with autism.
Oh my gosh.
And then we went and measured them before treatment and after treatment and used that to then do a follow-on study. The first study we did, the second study was a large study, 141 children and adults with autism. And we found some significant improvements in a number of areas. It's not huge, but again, any benefit in treating an otherwise incurable lifelong disorder is very helpful. Side effects were minimal. Some of the major differences we found were low levels of biotin, and we found that the lower the level of biotin, the more likely they were to respond to a vitamin mineral supplement. But also low levels of vitamin K were very suggestive of responding to a vitamin mineral supplement. Those two vitamins have totally different functions, but what they have in common, and it took us about 6 months to figure this out, that those two vitamins are made mostly by your gut bacteria and are produced only to a small amount. You only get about half or so from your food. And so that gave us a clue that kids with autism were missing some important gut bacteria that make some important vitamins. So it was one of the clues that gut bacteria were important.
Okay, now we have to freeze frame that right there, Jimbo, because that is a very extremely interesting point. And there are a lot of people who are listening like, what in the heck are you talking about? Because you said something that's transformational for so many people, and that is your gut bacteria. What we often think about so often is the gut bacteria are doing something to digest things and break them apart. But the whole idea of like creating a vitamin and actually having something come from your gut bacteria, which creates a vitamin supplement, is a completely transformational point. Now, and I know a little bit about this. I don't know as much as you know. I told you I was intimidated talking to you right before we even got started because I know you know so much more than I do. But I know a little bit, and I know that the gut can actually create brain-derived neurotropic factor. So that, to me, was interesting. But this is the first time I've heard that you could actually have these particular supplements, vitamins, come from gut bacteria. So now it's part of the microbiome that we're talking about.
That's right. That's right. So the microbiome plays many different important functions in the body. People normally think of it as just for helping digest food, and that's certainly important. The microbiome also regulates motility, so it keeps the food mass and waste mass moving through the GI tract so you don't have constipation. It regulates water absorption, so you absorb water from your gut, and you don't want to absorb too much because that would make the stool too hard, and you don't want to absorb too little or you have liquid stool. So regulates water absorption. It makes a number of vitamins, especially vitamin K and biotin, but also some amount of some other important ones like folic acid that I'll come to later is very important for preventing autism. And then also it's very important for producing what are called short-chain fatty acids. So certain bacteria, only a few bacteria in your gut, eat the fiber that is in your diet. So you get most of your fiber from your whole fruit and whole vegetable. So if you eat an orange, you get a lot of fiber. But if you drink orange juice instead, you get zero fiber or near zero fiber. Mm-hmm. That's very important to eat that whole orange and not drink the glass of orange juice. That fiber is converted by certain bacteria into some short-chain fatty acids. One of those short-chain fatty acids, butyrate, is a major producer of energy for the body. It provides about 5 to 10% of all the energy for your entire body, but most especially it provides about 70% of the energy for the cells that line your gut.
Is that right? I'll be talking
about most people in the U.S., the recommendation is to consume 20 to 40 grams of fiber today. Average American consumes about 11 grams. So less than half of the lower end of the recommendation. So Americans just aren't getting enough fiber. Because of that, they are not making enough butyrate to feed the cells of their colon. So the cells of their intestine are literally starving for nutrients. And that's, we believe, the reason for the wide range of GI problems. Not the only cause, but probably one of the major, not the major causes, we think, of many GI problems, from irritable bowel syndrome, constipation, to more severe conditions like ulcerative colitis and Crohn's disease. It's just, if you aren't feeding the cells, if they're starving to death, no wonder they become diseased. But also, one of the challenges that when the cells are not fed, then the gaps between the cells occur, and it's possible for partly digested food or waste products to leak through this gut. Some people call leaky gut or intestinal permeability, and those foods, partly digested food and waste products, leak into the rest of the body and can cause food allergies and cause immune problems. The body recognizes these are foreign substances that shouldn't be in the body and mounts an immune attack against them. So the gut is very important in regulating the immune system. Roughly 70% of the immune system is centered in the gut, because that's how you get exposed to most bacteria and viruses, through the food you eat, the water you drink. And so that interplay of the gut with the immune system is very important.
Well, let me ask you a somewhat innocent question from a person who doesn't understand the complexity as well as you do. And I want to talk about zonulin in just a minute. We'll talk about that just to prepare you. But coming back a little bit, if a person wanted to put fiber in some kind of helpful way without knowing the details that you're talking about. If, for example, a person said, well, I need more fiber, I'm just going to do psyllium, or I'm going to just do flaxseed meal, both of which have a certain measure of soluble and insoluble fiber with them. Could you comment a little bit on that? Because it seems so commonplace that people think about those things.
Yeah, I think certainly adding fiber or fiber-rich supplements makes sense and is a good thing to do. But I always like to think back to what have people been eating for the last million years. And so they've mostly been eating whole fruits, whole vegetables, in some more recent cases, whole grains to get their fiber. So I think I'd really like to focus on more of the fiber from fruits and vegetables and less the fiber from grains. Again, we'd like to see more research as to what is the best type of fiber. Mm-hmm. If you have bacteria, we don't know for sure. Mm-hmm. But unfortunately, it's also just getting the fiber is not enough. What's also important is to have the right bacteria. There are only a few strains of bacteria that will take the that will take the fiber and convert it into the butyrate that is needed to feed the cells.
Oh, good. So, well, let's hit those if you don't mind. Can we talk about those a little bit?
Well, there are several of them. One of the bacteria that we're most interested in is called Prevotella. We became interested in it because we found in our first study of gut bacteria in kids with autism that it was much lower in children with autism than in typical children. Mm-hmm. And so we went to do some more research on it. One of the important functions it has is it produces butyrate. So Prevotella is one of several bacteria that consumes fiber in your diet and converts it into butyrate. That's the food to keep the cells of your intestines healthy. Now, we then went on and found a fascinating research study on people on traditional Aboriginal diets in Africa, where they're eating healthy, high-fiber diets, rich in beans and whole foods. And in those population, roughly 50% of their bacteria is Prevotella, and they have very healthy guts.
Is that right? Very interesting.
If you compare that in the same study, they compared European children. European children, instead of having 50% of their bacteria being Prevotella, it's less than 1%. In Americans, it's even a little worse than Europeans. And kids with autism are an order of magnitude worse than that. The Prevotella levels are so low, in most cases, we can't detect it.
Wow. That is so interesting.
50% is ideal, and kids with autism are 1,000 times less than that, roughly.
Oh my gosh.
But we were excited about Prevotella. We went on to do a second study, and we found the same thing. Kids with autism are low in Prevotella, and they also just have general low diversity of gut bacteria. So most people have of order 1,000 strains. Kids with autism are missing several hundred species of bacteria from their gut. So that was the other issue. We noticed when Prevotella was high, pathogens were low, and when Prevotella was low, pathogens were high. So we can't say cause and effect. All we can say is that Prevotella seems to be associated with a healthy diet, with fiber-rich diet, and when it's present, bad bacteria are not.
Well, you know the natural question. You know what I'm going to ask you right now. How can you get Prevotella? Does it come in a pill? You have to take a mud bath? How does all that happen?
Great question. Unfortunately, there are only a few probiotics that are available commercially that have been grandfathered in by the FDA. And so you have about 1,000 species of bacteria in your gut, but the ones that have been grandfathered in are generally the species that grow in milk, in air, in oxygen. But most of the bacteria in your gut are what we call anaerobic bacteria, ones that don't grow in oxygen. Oxygen kills them. So although probiotics are in principle a good thing and may have some limited benefit, the problem is they generally are not the bacteria that grow in your gut. So Prevotella, like 95% of the bacteria in your gut, would require an FDA investigational approval, would be classified by them as a potential new drug. And so my colleagues have a patent on the use of Prevotella for treating children with autism, but we'd have to raise a lot of money to go and do the studies to prove to the FDA it's safe and beneficial. So the short answer to your question is you cannot buy Prevotella over the counter today. The FDA won't allow it. It's easy to make, easy to produce. We'd have to do a lot of human studies to show that it's allowable. Even though most people have a little Prevotella in their gut, and we know high amounts are good, the simple way to get Prevotella levels increased in your body is to exercise. But it turns out athletes, a paper just came out showing the more you exercise, the more Prevotella you have in your body. Now, we don't know if that's because indirectly the people who exercise eat healthier, maybe, and maybe the exercise indirectly helps.
That is so interesting. So, you know, what I got excited about, I was interrupting you there for a second, was the next question, which was somewhat similar. We're still talking about what we could do to actually fix this situation. So where are you with this inoculation of microbiome? I can't remember the term for it. I've read a little bit about it. I don't have any direct experience with anybody I've worked with, but what's your opinion about that? And could Prevotella be associated with an inoculation like that?
So the answer is yes. Prevotella that's a great way to get it. So maybe I should back up briefly and talk about what's normally called fecal transplant, but we have a new term for it because we do it differently. So if it's okay, I'll just briefly mention there's a really nasty condition called Clostridium difficile or C. infections. They're on the rise in the U.S. They affect about 100,000 Americans a year, and they're life-threatening. Causes life-threatening diarrhea, explosive diarrhea. It can be treated with antibiotics, but it frequently comes back again and again, and it kills about 30,000 Americans a year.
Wow.
Almost as many as die in car accidents.
Really?
Really a nasty bacteria. So it turns out if you take just a little bit of poop from a healthy person and put it into that sick person, within 2 to 3 days, they go from literally being extremely ill, dangerously ill, to being completely cured in 2 to 3 days with about a 90% cure rate. Just one dose, one time, 90% cure rate. You can give it through a colonoscopy. You can give it through a rectal enema. If you're brave, you can do a nasal gastric tube down into the stomach. Doesn't matter too much how you get it in. 90% cure rate. And the best part, no significant adverse effects, and it almost never, C. diff is essentially never returns. Unlike antibiotics, it often returns again and again. So the FDA, because there are now 25 studies showing the benefits of this, but no one wants to spend the typical $1 billion to bring poop to the marketplace to get it approved by the FDA.
It's an anti-marketing term.
Yep. So it's a real challenge, but it is, the FDA has therefore allowed the use of fecal transplant in the U.S. for people who have recurrent C. diff only. So we work with a company that's treating 1,000 people a month at many hospitals around the country. It's just fantastic. But we decided to go ahead and try treating children with autism. And the reason for this is a little complicated, but I'll explain briefly if I can.
Please.
There was a study back in 2000 where 11 children with autism were treated with vancomycin. It's a special antibiotic. When you drink it, it stays in the gut, doesn't go in the rest of the body. So it makes it very safe because it's not absorbed. They treated them for 8 weeks, and during 8 weeks, their GI symptoms greatly improved, and surprisingly, their autism symptoms greatly improved.
Really?
But then when they stopped treating, then within a few weeks, the GI benefits were lost and the autism benefits were lost, even though some of them took standard probiotics. So the analogy I like to give is like having a garden filled with weeds. The vancomycin pulls all the weeds, gets rid of all the bad bacteria. But if you do nothing, what's going to happen? The weeds are going to regrow in that garden. So what we want to do is both weed and then reseed. Mm-hmm. And that was what we chose to do in our study. So we worked with a physician in Australia, Tom Brody. He's treated 5,000 people with fecal transplant. He's the world's expert on it. Treated 9 children with autism who had GI problems. He found that they were much, much harder to treat than C. diff patients. Instead of 1 dose, he treated them daily for 3 months. And slowly, gradually, their GI symptoms improved. Slowly, gradually, the parents reported their autism symptoms began improving. Never published it because he's just a physician treating his patients. But he shared the information with me. I shared it with the FDA and asked the FDA, could we do a study? And so the FDA allowed us to go ahead and do a study in which we took 18 children with autism. These had all had GI problems since infancy. They were ages 7 to 16. They had never had a period of normal GI health. Since infancy, it had chronic constipation or chronic diarrhea or alternated between the two. We treated them for just 2 weeks with vancomycin to kill off the bad bacteria. And then MoviPrep, which is a bowel cleanse. If you've ever had the joy of a colonoscopy, it just cleanses you right out. But we wanted to get rid of any remaining bacteria, get rid of the vancomycin, and then we put in the beneficial bacteria. So we had some super healthy donors, very carefully screened, and their stools were purified, so it was just bacteria that was left. And then we gave it to them every day, and slowly, gradually, by about 5 weeks into the study, the GI problems were mostly treated. By 10 weeks, 80% reduction in GI problems, and autism symptoms had improved about 25% by then. We then stopped treatment and waited 8 weeks to see would we lose benefit or would the benefit be stable. And sure enough, the benefits remained.
Oh, fantastic.
80% reduction of GI symptoms, still very good improvement in autism symptoms. In fact, a year later, several of the families independently came up to me and said, Professor Adams, my son is doing better than ever. So, wow, it's really interesting. So we raised the money to do a follow-up study. So in this first study of 18 children, we had 0 dropouts. That's very rare in a study. No one dropped out. 2 years later, we followed up with every family. All 18 of them agreed to be interviewed again, and most of the GI benefits had held, about a 60% improvement compared to baseline. The autism symptoms, I can't say too much more because we haven't published this yet, so I'll just say that
there was an improvement.
I'll just say that.
Yeah.
So some things I can't say because we haven't published it yet.
Yeah,
so it's
sure.
promising. And so we also looked at the gut bacteria. Before the treatment started, the kids with autism were missing several hundred species of bacteria. So they were missing about 25% of their normal gut bacteria. By the end of treatment, their diversity of gut bacteria had normalized. Generally, the more diverse the gut bacteria, the healthier your gut. And at the end of 8 weeks after stopping treatment, those benefits were still there.
That is so interesting.
Yeah. And we've seen other studies of fecal transplant. At one study I was just looking at for chronic fatigue, 70% cure of chronic fatigue. And when they followed up with some patients 15 years later, still seeing very good benefits. So
that's amazing. Yeah.
Really interesting.
Okay. So let me ask you this question, because I'm thinking of the mothers out there who are thinking about their kids.
Yep.
How did that transplant take place? In your study, did they do it through a colonoscopy, or how did they actually get those bacteria in that gut?
We tried it 2 different ways for the first dose. So the first dose was a very high dose right after the bowel cleanse. In some of the kids, we gave it to them orally. It's essentially like a probiotic, just highly purified bacteria, and they just mixed it in chocolate milk because it was a little bit of a brown color still, and they just drank it down. It was virtually odorless, virtually tasteless. The other kids, bless their hearts, had a very deep rectal enema, and our physician was very good. They put it deep into the kids, carried the kids prone to their car, prone to their house, and they kept it in for many hours. And we followed it up daily with just a low maintenance dose. Again, they just put it in their favorite drink, drank it right down like a probiotic every day for 7 to 8 weeks. And so it's looking very good.
So you were controlling for the route of administration as well.
Yeah, and it turns out it doesn't seem to matter. Within our small sample size, both routes seemed equally effective. Probably the maintenance dose that was more important, because the benefits didn't occur right away like with C. diff. It was just like C. diff. Within 2 to 3 days, it would have been cured. No way. It took 5 weeks or more for them to see most of the GI benefit. It took 10 weeks to see most of the autism benefit. But let me mention one important clue you'll appreciate as a psychiatrist is that in the first study back in 2000, they found that when they gave vancomycin alone, the first day or 2, the children got worse before they got better. We think what's happening is as the antibiotic kills off all the bacteria, then the bacterial cell walls are burst and all the toxins are released all at once. So the symptoms the toxins were causing get worse, and then they get better. In our study, we found essentially the same thing. 2/3 of the kids had an increase in hyperactivity or irritability. And those symptoms were very short, usually just a day or 2, and usually just the first day or 2 of taking the Vanco. And then they got better. So we call it a die-off reaction, all those toxins. We now know which kids were most likely to have that die-off reaction. It's the kids who had worse of those symptoms to begin with. If you had more of the bacteria that are causing you to be irritable, causing you to be hyperactive, then you're going to have worse symptoms when those bad bacteria die off.
That is absolutely amazing. You know, I've had the experience. I haven't been as deeply involved. That's why I say it was interesting having the chance to talk to you, because I knew you knew so much more about this, but we've worked with Candida. And, you know, you see a Herxheimer reaction with Candida. And when I first started doing it, I didn't know what the heck was going on, because I thought, hey, I'm helping these people out. And they would get worse because it actually then, what I ultimately realized is that the bugs formed the biofilm, because when I started with the Candida, I was using nystatin based on what would be the ordinary expected protocol.
Sure.
And then later on, I've gotten away from nystatin because I just realized that they're going to form biofilm on it. And so then I've gone with products that are going to actually eat the biofilm. But the bottom line is that whole Herxheimer thing is a big deal. And what you're saying is it's a Herxheimer reaction.
Yep, can produce alcohols, which obviously can affect your mental function, and they can produce a lot worse toxins too. There's a survey data from ARI of 26,000 families, and the number 2 rated treatment above any psychiatric medication for autism is nystatin and diflucan, the antifungals. Parents just report it often helps their child's symptoms. We did the first study of levels of yeast in kids with autism. We looked at it two ways, both by culture and under a microscope, and not much difference. Kids with autism had a little bit more, not quite enough to be statistically significant. We're looking at that again in a new study with much better methods, but we think that probably they're even just vulnerable to small amounts that they're exposed to because they have more intestinal permeability. And as you say, we measure what comes out in stool. If it's present lining the GI tract, we can't see it easily without a biopsy, and that's pretty invasive.
So I was kind of anticipating where you might be going with that conversation, but it sounded like you were moving in the direction that the Candida that we've been seeing and treating is not quite as persuasively important as the microbiome issue, and that the Candida is almost an ancillary, but nevertheless related situation to the microbiota problem.
Yeah. So I'll say our first study in 2011, we used simple culture methods with doctors' data, and we found that there was slightly higher, so maybe 20% of the kids had colony-forming yeast versus 10% in the control group. That wasn't quite enough to be statistically significant. It was suggestive there might be something of an issue. But no one's done a formal treatment study of antifungals for autism. It's on our to-do list. All I can say is we could definitely have big improvements in GI health and someone in autism symptoms by getting rid of the bad bacteria. What if we go after yeast as well? Or just by altering the gut bacteria, is that indirectly affecting the yeast? So with my brilliant colleagues who do the measurements, Rosie Krujmalnik-Brown and Daewoo Kang, we hope to look at that soon.
See, that is such an interesting point. Now, let me ask you this, and I don't mean to put you on the spot because I know just a little bit about this, but I'm asking this question from a point of innocence, not anything else. But I know a little bit about biofilm, so I'm a little bit, if you might call it, a biofilm fanatic, because I had so many treatment failures using nystatin. I never did use diflucan, but I used nystatin. And they would do well initially, and then they'd come down 2 or 3 months and they would all be back again. So then I got into biofilm and I began to read much more about it. And we use some supplements, as I mentioned a moment ago, that actually erode the biofilm so they can get in. And biofilm, for listeners, is mucopolysaccharide covering. The Candida, this is just a little bit. They actually communicate with each other. It's a thing called quorum sensing. They actually talk to each other and they form a colony, which is what we were talking about, what Dr. Adams was talking about. And then because they have this mucopolysaccharide covering, then the diflucan or the nystatin can't penetrate it, and the symptoms reoccur because the colonies are there. And with the colonies, then the gut continues to be a leaky gut, and they continue to have the gut-associated lymphoid tissue and all the gastrointestinal symptomatology, and they don't respond well to the antifungal. So then that's when I got over into this other thing. But here's what I'm beating around the bush to tell you, because I said that because some of the listeners may not know what we're talking about. But what I wanted to ask you is, does it appear that the microbiota form the bad bugs? Do they form biofilm? Is biofilm a factor in what you guys are interested in? Are you thinking about it, or is it not relevant for you?
Well, we are limited into what we can measure. So we're mostly doing non-invasive measurements. So we're stool samples. We're looking at what's in the blood of the children. So we're doing a lot of measurements of metabolites in the blood. But the issue is that, yes, bacteria and yeast can exist in colony forms. I'm an expert on that. My collaborator, Rosie Krujmalnik-Brown, could say more. But even after something like a bowel cleanse, where you're removing most of the bacteria, they mostly reform. Your appendix actually is important. It appears one of the major roles of the appendix actually is to serve as a repository of your gut bacteria. So if you have a bad gut infection, it can then repopulate the gut. So we believe that's one of the important roles of it. I think coming back to looking at our children with autism, what we've learned is that you inherit most of your microbiome from your mother, normally as part of the birth process. Birth is very bluntly a very messy process, a lot of pressure on the mom's bladder and bowels. And there's going to be, you look at where the child's nose and mouth are pointing towards mom's bottom, there's going to be some seeding of the gut bacteria from the birth process during a normal vaginal birth. But if you're born by C-section, then you're going to miss some colonization. So quite a few studies looking at different gut bacteria in kids who are born by C-section. So we've noticed in our study, we found that 60% of the kids in our study were born by C-section, the ones who had autism and GI problems. We also know that their mothers had lower fiber intake, and because we evaluated mother's dietary intake and child's dietary intake, and both mother and child had lower fiber intake. So think of it this way. Mom probably had worse gut bacteria to begin with because of low fiber intake. Then being born by C-section, you get even less of that. And then the kids with autism in our study, and we've seen this in several previous studies, have more antibiotics as well during infancy. So we found 2.5 times oral antibiotic use. So whatever has managed to miraculously get into the gut is then often largely wiped out by the gut bacteria. And then these kids are on lower fiber diets and again getting less of that. So all this cascade of problems we think are a big part of what is a clue to why kids with autism have these GI problems. Another big part is just 100 years ago, this radical invention called a toilet. So there's now a lot less contamination. People wash their hands. And so unlike dogs who eat one another's poop, humans get very little contact with other people. And we think that's contributing to the decreased diversity, low fiber, antibiotic use, and better sanitation.
So that is so darn interesting. I'm so much appreciating you taking the time to tell us about this, because I know a lot. I mean, this is really, really useful, helpful, and encouraging information all at one time. It's really quite interesting. Now, one thing we alluded to, and we said it in passing when we first started speaking, the issue of prevention. Let's talk just a little bit about that from your perspective. I mean, obviously, these things are way too complicated to hit in a short conversation like this, but if you could just give us a little bit in that direction, I think people would be very interested in your thoughts about that.
Yeah, so we've done a fair bit of work on this. Briefly, we know that roughly half of autism is genetic, roughly half of it is due to environmental issues. The genetic issue, about half of the genetic variations are de novo mutations. So weren't present in the parents, are present in the child. What would cause that? And so one of the issues that we think is very important is folic acid during pregnancy. So we know that folic acid has been approved by the FDA as being very important in preventing birth defects, especially spina bifida. For autism, there have been several studies mostly showing that mothers of children with autism have less folic acid in their blood compared to mothers of typical children. They have lower folic acid intake. And that bottom line is that these epidemiology studies suggest that if you take folic acid near conception, 40% lower risk of having a child with autism. But if you wait until you know you're pregnant, 2 months into your pregnancy, it's too late. It doesn't have benefit. You have to have the folic acid early in the pregnancy when the brain is just beginning to form, the most crucial development time. So we've been doing a study with Mayo and looking at mothers of children with autism. Turns out that folic acid works in conjunction with another key vitamin, vitamin B12. We've measured those levels and found B12 is also low in mothers of children with autism. One of the important things that folic acid and B12 do is they regulate what's called methylation, which basically controls turning your genes on and off. So there's some studies which show that children with autism are undermethylated. Their genes are not properly being turned on and off, and that's causing a lot of the problems in autism. So we think that getting folic acid and B12 at conception or before conception would help prevent not just 40%, but maybe even more, 50, 60% of cases, we think.
Well, that's very interesting. Now, let me ask you, this is a little bit of a deeper question because I know, again, a little bit, but read some things that discourage people from using folic acid. I'm not disagreeing with you because I don't know what you know. I'm just talking with you about this. And people say folinic acid, which is the more natural form, is the right way to go. So I'd be interested in your thoughts about that. That's a little picky, but I mean,
No, you're totally correct. You're totally correct. The research studies have been done with folic acid. That's what people use. But folic acid is an artificial form of folate that doesn't exist in nature. We put it in vitamin mineral supplements because it's cheap and it works well in mice. But it turns out that mice have a pretty good ability to convert folic acid to the active forms of folate. But some humans are very bad at converting folic acid to folinic acid and other forms. So folinic acid is one of the natural forms that exists in nature. So we think that it makes much better sense to give folinic acid. And in fact, there was a study that was just published showing that if you took high amounts of folic acid during pregnancy, it increased your risk of allergies in the children. And of course, we have a big problem with allergies on the rise, and this seems to be one of the contributing factors. Whereas if it anti-correlated with levels of active forms of folate. So if you had high levels of the active form, you were less likely to have these allergies. So bottom line is, take folinic, not folic. We need more research to be sure, but that would be my recommendation.
Thank you so much for weighing in on that. I didn't put you on the spot. You were right on top of that. I mean, I thought it was kind of an arcane question, to tell you the truth. I really appreciate it.
We actually developed a vitamin mineral supplement for autism because they found that folic acid didn't help the kids with autism, and folinic does. So we've now produced a vitamin mineral supplement for kids with autism, and we're working on a prenatal.
Well, that is so terribly interesting. I really very much appreciate it. Now, I want to ask you something else, Dr. Adams. Let's talk a little bit as we close, because we're really out of time here, but I want to make sure that people can get connected with you if you would like them to. I don't know, a person who's a researcher and a professor like you probably doesn't spend a lot of time doing social media, but the interest that you have, the things that you're talking about are so interesting. Do you have at the university a website, or do you have anything that would be available for people in that regard, or what would you recommend?
Yeah, so I have my main university website, which has a few articles on it, but the website for families, which is a lot more informative, is Adams, ADAMS, autismresearch.com. And so we have a lot of recommendations there for families, talks about many of the issues we've discussed and a lot more.
Thank you so much. I'm so glad. I was looking around on your bio and I just couldn't find it. You had, for those of you, we have Dr. Adams was kind enough to send me a couple of his papers, and I was looking at the papers. I got all interested in the papers, and I didn't do my homework exactly getting the website, so I'm just so glad it was there. So, well, thank you so much for talking to us. We really appreciate it. It's terribly interesting, and as you come along, feel free if you say, "Hey, Parker, here's something else people would get to know about." Maybe if you develop a product and you want to get that product out there and you say, here's something people can use, we'd be happy to have you back, because this is very engaging, very interesting. And we just love the fact that you're so scientific about it. You're thinking about this in really good peer-reviewed terms. You're doing the work. It's not just, hey, this is a great idea, give it a shot. These are people that are really working hard on these projects, and you're one of the thought leaders. And we just really appreciate you taking the time to come and talk to us.
No, you're very welcome.
Thank you very much, sir. You have a great day.
Thanks. You too, Chuck.
Thanks for listening to CoreBrain Journal. We're working every day behind the scenes to bring you reports that connect research benches with those street trenches. Here we share the complexity of mind science because, as you know, details really do matter. One of the most pervasive, misunderstood challenges is how commonplace medications, like those written for ADHD, are used so regularly without clear guidelines. If you think you'd like more specifics, take a minute to download my 2-page PDF packed with video links and references on the absolute essentials of how to start ADHD medications. They're easily available at CoreBrainJournal.com/start. Thanks for listening. Do connect and stay tuned. Together we can make a difference.